Hello! Today we're going to talk about simplifying exponents, which can come in handy in problems like these, where you're not only dealing with addition, subtraction, multiplication, division, but now you're dealing with exponents. And being able to simplify these expressions can make your life a whole lot easier. So, before we continue on, I just want to do a quick recap of some exponent basics. Please check out my other video for further explanations. But in an exponential expression like 2 to the 5th, this is a power, so this is 2 to the 5th power. 2 is our base, that's the number we're multiplying by. 5 is the exponents, and that's the number of times we're multiplying by the base. So 2 to the 5th becomes 2 times 2 times 2 times 2 times 2, which comes out to 32. Well, you can see here I have written some other powers of 2. And so 2 to the 4th is 16, and we keep going until we get to 2 to the 0. Any number raised to the 0 power is 1. Again, check out my other video for a further explanation. Well, once you start getting into negative exponents, you're actually doing the inverse operation. So instead of multiplying by the base, you are dividing by the base. So 2 to the negative 1 power is 1 divided by 2. 2 to the negative 2 power is 1 divided by 4, and so on and so on. Okay, now that we've gotten that out of the way, let's talk about order of operations. Well, when you're evaluating expressions with exponents, you have to keep in mind the order of operations. And the order is first you evaluate what's inside the parentheses before you do anything else. After that, you evaluate all of your power expressions, and then you do multiplication and division from left to right, and then you do addition and subtraction from left to right. It's an important note that when you are adding inside parentheses and you have an exponent, something like a plus b, and that whole thing to the second power or squared, you do not distribute the power. I repeat, you do not distribute the power. So this does not equal a squared plus b squared. So if keeping that in mind, let's evaluate this expression here. Well, first we evaluate, so step 1. Oops, there we go. Step 1 is parentheses. Well, 5 minus 2, that becomes 3, and we keep the squared for now. 2 minus 5 becomes negative 3, so we get negative 3, and that becomes negative 3 to the 3rd power. Okay, step number 2 is powers. Step 2, powers. Okay, well, 3 squared is 9. What is negative 3 to the 3rd power? Well, let's expand this out. This becomes negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3 is positive 27. And then we multiply that by another negative 3, which gives us negative 81. Okay, so then we say 9 plus negative 81. Okay, well, we don't have any multiplication and division, so we skip that step. So the next step, which is step 3, and this would be addition. So we get 9 plus negative 81, excuse my terrible handwriting, and that becomes 72, which is our final answer. So this whole thing becomes 72. Okay, let's move on to some more properties of powers, starting with the product of powers. When we have something like this, where we say a to the 3rd power times a squared, or a to the 2nd power, well, what does that become? Well, if we expand this out, we get a times a times a, and this is a to the 3rd. And then we multiply it by a squared, which is a times a. This is a squared. Well, when we do all of this, we get, that's the same thing as a to the 5th power. So more generally, a cubed times a squared is going to give us a raised to the 3 plus 2 exponent, or a to the 5th. When you multiply powers, as long as it's the same base, you add the exponents. Well, the same thing here. When I have a to the fifth divided by a squared, that's the same thing as a times a times a times a divided by a squared, which is a times a. Well, we know, if you know fractions, you know that you can, forgot an a there, cancel those out, so you're just ending up with a times a times a, which is a to the third power, or more generally, a to the fifth power divided by a squared gives us a to the fifth minus 2, which gives us a to the third, or a cubed. So when you are dividing two numbers that have the same base but different exponents, you subtract the exponents. Now remember here when I was talking about how when you're adding inside the parentheses you cannot distribute the exponent? Well, if you're multiplying, you can distribute by the exponent. So a times b, that whole expression squared, that becomes a squared times b squared. Same thing with division here. A divided by b, that whole thing squared becomes a squared divided by b squared. So you can distribute when you're multiplying, you cannot distribute when you're adding inside parentheses. Okay, moving on. Power of powers. Okay, so when we raise an expression that has powers to another exponent, so a squared, that whole thing wrapped in parentheses raised to the third power, what does that become? Well, let's expand out a squared, so that's a times a, and we're multiplying that because we're doing to the third power, so this becomes a times a, and finally a times a. Well, this becomes 1, 2, 3, 4, 5, 6, or a to the sixth power. So more specifically, a squared raised to the third power becomes a raised to the 2 times 3, which is a to the sixth. When you raise a power to a power, you multiply your exponents. Okay, so let's do a few more problems. Well, how about this one? We have, I'll say, problem 1. Okay, so we have, how about 5 plus negative 6 cubed, that whole thing, 2 times 3 squared. Okay, order of operations again. So first thing we do is anything inside the parentheses. Well, we do have parentheses, but there's nothing happening in there. It's just negative 6. So we can skip that step. There's nothing to do inside parentheses. Step number 2 is powers. Okay, so we have 5 plus, okay, what is negative 6 raised to the third power? Well, that's negative 6 times negative 6 times negative 6, which ends up giving me negative 216 when I multiply those things out. So I have 5 plus negative 216, and then over 2 times 3 squared. Well, order of operations, we're still on our powers, so we say 2 times 9. Okay, next up is multiplication and division. We do have a multiplication step here, so I'll say 5 plus negative 216 over 18. Okay, well, now we can do our addition and subtraction. So what is 5 plus negative 216? That gives me negative 211. So this becomes negative 211 divided by 18. You could go ahead and do the division and get a decimal answer here, but I'm just going to leave it like this, so I'm going to say we are done. So we have successfully simplified this expression. Okay. How about another problem? Oops, there we go. Problem 2. Okay, this one is going to say, we're going to say n squared equals 2 to the 6th power. We want to solve for n. Okay, so how do we do this? Well, let's take this expression and see if we can simplify it and get this exponent to turn into 0, right? Turn into 2. Well, 2 to the 6th, that's the same thing as, okay, so we know that we can subtract, or we can divide. So why don't we say let's divide. This is the same thing as 2 raised to the third, and that whole expression raised to the second, right? 3 times 2 is 6, same base. So we have 2 to the 6 equals 2 to the third, that raised to the second power. Well, now, and with that, again, still equals n squared. Now we have the same exponents, so n, therefore, n is going to equal 2 raised to the third, or 8. Final answer. Here we're using the power of powers rules. Okay, let's do another one. How about... Okay, let's try 2 raised to the 5th, that whole thing raised to the 6th, and that whole thing raised to the 3rd. Okay, well, we have a 2 and a 4. Well, how can we write 2 as a function of 4? Well, why don't we just go ahead and do this step here? So we have this here, 2 to the 5th raised to the 6th power. We know that we multiply this, so this becomes 2 to the 30th power over 4 to the 3rd. Okay, well, we want to turn a 2 into a 4 to simplify it. So how can we do that? Well, if we rewrite 2, if we change 2 into a 2 squared, this becomes, we got 2 squared. So what happens to our 30? Well, we know we have to multiply by 15 to get 30. So we get 2 squared raised to the 15th to give us 2 to the 30. And then, oh, I'm sorry, let's see, did this a little backwards. Forgive me. Let me just redo this step here. Let's redo this. This is still 2 to the 30th, but this becomes 2 squared. So 4 can be rewritten as 2 squared, and that's raised to the 3rd. This is still raised to the 30. So what does that become? Well, 2 to the 2nd raised to the 3rd, that becomes 2 to the 6th, power of powers. And this is still 2 to the 30th. Okay, and now we know that we can divide. When we divide by this, we subtract the exponents. So this becomes 2 raised to the 24th power. And that is a good enough simplification for me here. Square answer. Yep, okay. Here's a good one. Problem 4. Okay, problem number 4. 100 raised to the 3rd power equals 10 to the what? 10 to the n. What is n? Well, let's change 10 into 100. So that would be 100 squared. So that would be 100. Oops, and there we go. And 100 cubed. Okay, 10 to the n. Well, if we can rewrite 10 as 100, so that would become 10 squared. And then, well, what do we get over here? We get n over 2, right? N over 2 times 2 just gives you n. Okay, so now we can see we have 100 cubed equals 10 over n over 2. So what is n over 2 equals 3, or n equals 6. Yep, okay. And we're going to do one more, and this one, actually, that's it. Please subscribe to my channel and leave some comments and like my video, and stay tuned for more to come. Thank you so much.